Okay, so quick note about the construction of the turbine axle shaft and all of the little pieces that are holding it together. So, if we take off our outside guide housing, this thing basically just keeps the steam closer to the discs so that the discs don't have as much of a gap, and also it's fairly smooth, unlike the actual outside housing, which is very rough and it has these little, you know, indentation things or whatever you want to call it. Splines. So this thing is the very first try, and I made the hole too big. I'm going to have to make another one, but realistically I'm going to make a much thicker piece of metal that goes all the way around. And I will get the exact size. Now, this axle shaft is... Hold on. This axle shaft is made up of a whole bunch of little components, and they have to be in the right order, at least for this design. And also, you can see now the problems with the disc warping that I was talking about. So these discs have a lot of warping that is making them touch each other like there. See that? It's terrible. And that is absolutely reducing the power and potential performance and efficiency of this thing. Mostly it impacts the efficiency for the steam to not have a perfectly parallel channel to run down. But it's not terrible. It could be worse, and we are going to rectify that by putting more of these washers around the perimeter. Now, this axle is made up of a whole bunch of little spacers. Now, if you look at this little cylinder, that would be the outside of the housing. So this hole, this little gap, fits over this cylinder thing. And you have a nut on the outside. The nut holds everything together. Then you have a flat washer. Now the washer has to be smaller than the diameter of the outer bearing race, because the idea is it sits on the inside race and it provides a little bit of a gap so that the bearing can rotate without rubbing against the nut. So in fact, I think even this washer is probably not perfect, but you can see the outside bearing race can rotate, and this washer kind of spaces it out. So that's a work in progress, but it's working. So then we just have a standard bearing. This is, I don't know what size it is, but I have a whole bunch of these. The reason I chose this specific size is because I have the most bearings in this size, and so when they wear out or get rusty, I can replace them. And one thing is, we're definitely going to try to re-grease them. We're going to try to take off these caps and maybe clean them out, see how nasty the grease is, and if necessary, re-grease them, or at least add more grease. And so then we have this spacer, which is not perfectly the right size for this shaft, but it's got a tiny bit of a play to it, you know. It's easier to show it. It's not perfect, but it's just small enough for this to work. And ideally, you would have the gap between this shaft and this housing to be as small as possible, and you would use a special type of seal, a gas seal that uses centripetal force to basically keep the gas from passing through it, and it uses a bunch of little... I mean, it's like a miniature turbine itself. It has all these little discs, and it has a path for the gas to travel through that's very convoluted, and that would provide you some amount of sealing when this thing's at speed. And so you have that spacer. Now we have the second nut. Now this nut is on the inside of the housing. This nut, when it's torqued down, provides enough pressure to hold the disc stack together, and also to firmly fix it to the shaft, so that when the discs rotate, the shaft also rotates. If there was not enough pressure, these discs could potentially slip, and the shaft could spin without the disc spinning, or vice versa. And that would be a problem. Eventually that would cause wear, and it would wear away the disc, and then you'd have an even more unbalanced and, rattly turbine than it already is. So this nut sits on the inside of the housing, torques the disc stack down, and then, okay, let me go a little bit faster here. And underneath this nut, I have a few more things. I have a washer. This washer is just a little bit larger than the nut, so that the whole entire nut is transferring the pressure to it. And so I have this washer. Then I have an actual lock washer. If I can get it off separately. Probably have to get it off together. All right, we'll get it off together. So we have a lock washer. Between two normal washers, we have a lock washer. And then we have another washer underneath it. So you have normal washer, lock washer, then another washer. And then we have this thing, which is, what this is designed to do, is to distribute the pressure as perfectly concentrically as possible, and also as flat as possible, so that the disc don't want to warp, around it. It wants to hold the disc flat, and it's a pretty thick piece of material. And so that is literally just to hold the pressure and distribute it in a large enough area so that it is pressing down on the disc. Because underneath this washer is a continuous disc, but underneath this is the whole disc stack, and every one of these discs has holes in it in the center. On the outside, I have 10 holes, but on the inside, I have 8. So that mismatch is what allows the steam to always have a path to travel out of. So we have this washer, and then that is pressing on this larger washer, and this is holding and compressing the whole disc stack down. And then I have this little pin thing. Before I revised the design and added these washers, this pin was to get all of the discs lined up and keep them from moving relative to each other. So that keeps all of the discs in a perfect line so that the holes go all the way through. And you can't really see it. Okay, you can kind of see it. And this outer disc, there's an outer washer just like this, but it has 8 holes. It has all of the holes in it, and I have to remake that. It's definitely, one thing is the center hole is too big. I just didn't have one that size that fit. So I need to make a custom washer that has the exact dimensions and has all 8 holes and this little set pin thing to line it up. And so we're going to do that. But the main thing is I just wanted to show that axle and how it's completely built so that you have your, let me put it back together. You have your pressure plate, essentially. I mean, if you think about like a clutch, it's like a pressure plate. Then you have your thick washer that transfers the force or the pressure. So that transfers and distributes it onto this larger one. So it's pressing down, and we have this thick piece on the outside, but if you didn't have that, and if you had another standard disc or 2 discs, then you would absolutely need this this to distribute the force equally. I keep saying force, but it's not a force. It's it's pressure essentially from the nut. So, or you can say a force without motion. That would be equally valid. And then we have one of these standard size washers that fits on top. I feel like it's easier without a glove. Then we have a lock washer. That provides this essentially keeps the whole thing locked. I mean, it keeps everything from getting loose from vibration, because this is going to be vibrating a lot, and you don't want these nuts we don't want the nuts loosening and coming off, because then it's going to rub against the housing, and then it's going to just wear a hole in the housing, and then we have to remake that piece. That would not be good. So we have this lock washer. Ideally, you could have more than one. I'm kind of limited in my my thickness here due to the dimensions of the housing, but anyway. And then we have, on top of that, we have this spacer, and now we're going to the outside of the housing. The outside of the housing fits right over this thing. That's this hole. And I would have to put the whole thing together to... Oh, I forgot. Go back one. So, forget that. First you have the nut. You have to have the nut. The nut is very important, because the nut holds the whole disc stack together at the right spacing. Between every disc is a washer, actually 2 washers on the inside that's made of the same material as the disc. So it's like, it's 1 disc, 2 washers, 1 disc, 2 washers. Now, I can experiment with that, and I might cut it down to 1 washer, but just for the very first test, I was using 2 washers. So we're definitely going to try to improve the design. We're going to make more of these perimeter washers and bolts and space to try to hold the spacing exact and get rid of this warping. This warping is terrible. I really have to just make new discs. But then, I mean, between every disc one, the axle is also a washer, or 2 washers. And so then we have, on the very end, we have this nut, and that completes the inside of the shaft. I'm having a hard time tightening that. Let me try. Let me pause. Yeah, that just sticks a little bit. There's just some kind of debris on the axle, but whatever. This is the only axle I have that actually fits this thing, because you need to have the smooth part of the bolts to be wider than the threads, or at least you need to have an axle that has threads on both sides. I mean, that could work too, but the reason that I'm using this one is because it's the exact right length for this nut to be as close as possible to the disc without going all the way. That's why I have this whole stack of material. But ideally, you'd have the threads go even further down, and you wouldn't need this much. You would only really need, you know, like, you'd only need this lock washer and the nut, and then this thick piece to distribute the force. And it doesn't need to be this thick. It just has to distribute it, right? That's just the thing that I found fits the axle as snugly as possible. And so it's, you know, I have to work with what I have. I have not been able to go to a hardware store. I don't even have money. They stole my they locked my account. So anyway, and then on the actual housing, you have this, creating the space so that the bearing doesn't rub on anything. And then you have the bearing sitting on top. Then you have a washer. Now, ideally, you could have one that's even smaller than this, smaller circumference. And then on the outside, you have this nut. And that nut is what holds this nut holds the bearing in place, so that the bearing is exactly in the center, or you could say just slightly from the bottom of this bearing channel. And that's the entire thing. And so there's one other thing I need to talk about these discs, and I think I'll pause here and we'll be right back.